Okay, let's get started. Hi, everyone. So today I'm going to talk a bit more about the local developed environment of my company's application. Um, some of the challenges that we were facing are pretty common across teams, and some of them are fairly new because the type of web applications that we're building are evolving. When I started 2 years ago at my current company, prior to my current job, I was a front-end developer. I didn't really know too much about DevOps, but everyone else seems to know this shit. So if you're like me 2 years ago, didn't know too many applications, tools out there supporting your local dev environment, this would be the talk for you. All right, let's get started. First, a bit more about myself. I am a software engineer at Flatiron. We are a healthcare tech company. We build oncological database. So what we do is we integrate with different hospitals and get the cancer patients from different hospitals, enter them to our cloud database, and build big data database for research purpose. And particularly, I work for the data access team. So what we are building is this application called Gateway, and we deploy that to the hospital's network. So hospital staff can use it for things like managing consent patients or triggering data processing. When I started 2 years ago, because we were new in Japan, we didn't even have the repository on GitHub. So we got to decide like the name of the repository, the tech stack, and also figure out a local dev environment that makes sense to our team's needs. So it was a fun ride. I learned a lot from that process. For one and foremost, we want to build a consistent and translucent environment across different teams to avoid common problems like my application works on my computer but not on yours. And also we want to base our development environment on Linux because we know that's probably where the application will be running on. I know these are very common problems with common solutions out there. Think two common strategies for that is for using virtual machines, and another one is for using Docker. Both would create a isolated, encapsulated environment for you, but also comes with extra challenges. For example, with virtual machine, it's running its own operation system on top of the host OS. So there's some overhead and you might compromise on performance. When it comes to Docker, it's doable, but sometimes people find it hard to debug due to the isolated characteristics of a Docker container. And another thing that's a bit tricky to our team was I started 2 years ago and I got a ARM chipped computer, but all the other team members, the other two team members got an older computer with the chip, the Intel chip. So that means even if we went with the Docker route, we might still need to run that application in Docker on a VM for me. In order to ensure the consistencies across the setup, eventually we decided to go with the virtual machine route, but instead of running a local one, we decided to create a remote virtual machine. So things like an EC2 instance or GCP in the environment of Google Cloud, and then access that via the VS Code remote development tool. And we've been using that for over a year and a half now, and we really like the setup. It's very smooth for us, very easy to spin up and set up a new instance. We create a template and just duplicate that instance if we want to create a new one. It's easy to debug when you are developing SSH into that instance on VS Code. It just feels like you are doing it locally, and you can fully utilize like the debugging tools by in VS Code or provided by the framework. And on top of that, it's not biting into the local machine's memory or CPU use. So now we solved the first problem we had, which is to create a consistent environment on computers that is running on different chip architecture. And the second problem that we were facing is we realized that our application will probably need to run a lot of microservices to support. For example, the hospitals might be using different vendors to manage their data. So that might require us to spin up different kind of database for the app to test data extraction on. We also would need like things like authentication. We were also thinking maybe we would need to run OCR model in order to process the documents. So we want a streamlined communication between the app and the other services, which will be running on Docker. There's a couple options to do it here. For one, we can use Docker. Docker supports the exposure of ports that are running the services on, or maybe you can create the Docker network that you connect all the services to. But then we find it a little bit hard to manage port conflicts. As you can imagine, we might be spinning up more micro services in the future. And in order to do that, we have to keep track of what services are running on what port and make sure that we're not using the same port on the host side services. So now we're trying to find a solution for creating a central point for managing the services. And there is a tool available for doing that. That's to use a reverse proxy. For those of you who do not know what a reverse proxy is, that's essentially a communication layer that sits in front of your front-end application, and it would direct different requests made from the front-end app to the back-end services. And that's exactly what we needed. On top of that, a reverse proxy would be able to give you things like security. For example, the HTTP request can be direct to HTTPS. And also it helps to manage things like certificates. A common tool for doing reverse proxy, I'm sure a lot of people have heard of, is NGINX. But as we were doing more research, we found this tool called Traffic. And when people are comparing Traffic with NGINX, what a lot of people would describe that is that it's a very dynamic tool. And by that, it means it allows you to integrate with your backend provider, which in our case would be the Docker. It automatically detects the services running on Docker. It does so by observing the Docker daemon and look at the names of all the containers running there, and it creates this name resolutions. So now when, for example, you're calling the database, making requests to the database, running the Docker, you don't have to specify a port. You can just give it a predictable name, things like Docker container name dot localhost dot google.com. And on top of that, it also has dynamic configuration. So if anything changed in the configuration file, you don't have to reload and start the service. You might still be able to do that with NGINX. For example, create some sort of scripts and automatically, dynamically create the configuration for NGINX. But that means you still will need to restart the service. But Traffic manages everything for you. So that's the solution we end up with going. And then around 6 months ago, the business team broke the horrifying news that we'll have to support IE 11. And as you know, they stopped support of IE 11 a while back, so not a lot of the modern OS can no longer run that. So what we end up doing is we create another remote instance that lives on the same private network with the Linux instance that's running that application. And then we use the Microsoft Remote Desktop. For those of you who are too young to know what that is, it's basically an application that allows you remote access to the Windows desktop. And then we use that to spin up to access IE11. So yeah, just a bit of the wrap up. I talked about the 3 challenges that my team faced. The first is, as we see the popularity of the ARM chips and other kinds of chips, we might, more and more teams might start to have the need of creating a consistent dev environment across computers with different CPU architectures. And our solution to that is to create a remote Linux virtual machine and access that with VS Code remote development. With the rise of SaaS, we are starting to see more and more applications outsource some of the common functionalities, things like a payment, authentication, to different services. And that also means that more and more of the local dev environment would need the support of different kinds of microservices. And our answer to that is to create a reverse proxy. And in particular, we use traffic for that. And the third one I talked about is like some of the system I feel like are still using pretty old technologies, be it it could be because of fund limits or constitutional inertia of changes. So if your team happen to need to support IE11, this is basically our solution. Yeah, thank you all.